This presentation is on revealing and predicting indicators of schools that are and will produce high percentages of math proficient students. The data are retrieved from the Maryland Department of Education, and it spans a time between 2003 and 2016. The continuous target of the predictive data are standardized test scores in math for elementary and secondary level students in the state of Maryland. The standardized test administered by the Maryland Department of Education is the Maryland State Assessment, or the MSA, and that would be for the elementary level. The secondary level take the high school assessment, or the HSA. Many of the features of the school will be analyzed to assess if there's any association or influence or non-influence to the target. Any significant findings can be applied to schools that are struggling to educate proficient math students. So a great question to ask in regard to the project overview is, well, who cares? And the short answer to that is the federal, state, and local government. They care. They are highly invested in the education system because there's a lot of money that goes towards the budget of education in the nation. The federal budget towards education for the academic year of 2019, which is the current year we're in, is around $649 billion. In the state of Maryland, the federal and state have come together, and the budget for education is about $1.8 billion. And so it would be nice to know the return on investment. How well is all this money doing? And so measures like the MSA and the HSA standardized tests provide that efficacy on the curriculum and the schools. Parents also are huge stakeholders in knowing how well a school is performing in producing proficient math students. Their interests are clearly their students, and they would do well to know if the school is producing a better student, which would later become a constructive citizen. So another great question would be, well, why should I care? Well, today's students are tomorrow's workforce. And so that's one great reason to care. Also, the more education level one gets, the more probable one will be to work a full-time job. Also, as we all know, more education drives more salary over a career. Another interesting fact is 75% of crime are committed by students who dropped out of school. So it's another reason why we all should care. Lastly, when a school is productive, meaning producing good marks in math assessment, reading assessment, science, English, and the like, the real estate of the residing community of the school actually goes up. So when a school does well, the neighborhood does well. This project is looking at math proficiency, and the question can arise, well, why math proficiency? Well, knowing math helps the brain to think critically and helps individuals problem solve. And so math is critical in education for that reason. Also, most of math concepts are understood the same way around the world. It's a universal sort of language. So, concepts including math and subtracting, even algebraic concepts, are understood universally around the world. In 2015, over 70% of the workforce were STEM related professions and STEM related jobs. STEM being science, technology, engineering, and math. Um, and in the US, the economy has shifted from a manufacturing and agricultural workforce to a more professional and business service workforce. So the economy now, and even the jobs that are posted or listed now, are veering away from agriculture, and individuals are now looking more towards jobs that provide salaries and wages. As stated earlier, the data are provided by the Maryland Department of Education, and this is a clip of what you get when you go to the website. As you can see, the data are segmented by years and further segmented by attributes. So some of the attributes live in the same yearly table, like special programs and the math test scores and the reading test scores. However, other attributes are in separate tables. So you have the enrollment numbers as one table, you have the mobility rates as one table, you have the special programs as one table. With that being said, there was clearly a lot of data wrangling to get all the segmented yearly data and all the attribute data into one complete data set. And so, as stated before, some of the attributes were already together, most were not. And so, just to give you more of a sense of the attributes that were in or provided by the Maryland Department of Education, there are the school, of course, with its name, the year, the level of school it is, if it's an elementary school, a middle school, high school. Also, the attendance rates, the dropout rates, the reading test scores, the science test scores, teacher certifications. And that was interesting to see that you have some teachers that are or that have met standard certification, and then there's others that have advanced certification. Um, Other attributes were the special education students or the special programs, and the free and reduced meal counts. Once all attribute data were compiled by all years into respective tables, or all, so every year, every segmented year was now compiled into one table that had all the years in it. I had to produce a star table schema, and this is the exact structure of that star table schema. And so if you look in the middle, the school data serves as the fact table, and all the attributes are serving as the dimension tables. And so pretty much there are left joins from the attributes to the main school data, and this was the approach of getting all the segmented data into one complete data set. As a result, the complete data set comprised 20,150 instances and 57 attributes. Here's a snippet of what the data looks like. Here's another snippet of the columnar data by school and academic year. These are more columns just moving or scrolling through the data set. And as you can see, there are student mobility numbers. And student mobility refers to students who enter and leave within the academic year. And so, yes, all the columns and all my attributes are compiled into this one data set. Using Tableau, I wanted to see what are student enrollments per county. The trend for most of the county student enrollments are increasing, yet there are some counties where enrollment actually decreases. Looking at Allegheny and Calvert counties, they are examples of student enrollments actually going down. I am guessing, and I have to conduct further research, that this decrease could be due to the decreasing economy in these counties. It could also be because of failing schools, but both these counties are rural counties in the state of Maryland, and so I may lean more towards that, but I have to do the research. Because of the large differences in enrollment, especially when you look at a county like Montgomery County or Prince George's County compared to a Cecil County or a Talbot County, there definitely has to be some kind of discretization of the data, because that will definitely skew some of the numbers. Preliminary data exploration and descriptive analysis shows some associations and correlations, and I did this within Tableau. In this slide here, we can see that there is a positive correlation between enrollment, which is at the top, and wealth per pupil, which is in the middle, and expenditures per pupil at the bottom. However, there are two outlier counties. This is Worcester and Talbot counties. They have small enrollments overall. However, they have huge wealth per pupil. So this is something that I have to further research. Moving forward, I'll be using Tableau and SAS EM to look for exact variable skewness. I do anticipate that some of the variables will be skewed because the student enrollment by county are so different. Also, possibly there could be differences between the years. Using R, I will be transforming variables from text to number when possible. I do anticipate discretizing the counties by enrollment numbers. I'll discretize the target into groups as well. I want to discretize the special program data, particularly the data regarding students getting free and reduced meals. I plan on replacing any missing values with the average or the mean of the variable column, and I do plan on removing variables that may cause noise in the preparation. In R, the data models I plan to use are the association rules, multiple linear regressions, decision trees, and naive Bayes. I want to compare model outputs and produce the model with the highest accuracy. So I'll also be doing models in SAS EM, and within that application I'll be doing the linear regressions. I'll also do support vector machines and gradient boosting models. Lastly, I will do the ensemble model, hoping to get the highest accuracy possible, but that will be my approach to the predictive analysis. The secondary data set was retrieved from Kaggle. It is a data set that is comprised of education expenditure data of regional states from 1992 to 2016. It drills down to the school district level and all their expenditures, and I have further segmented down to schools in the South Atlantic region of the U.S. The South Atlantic region of the U.S. are Delaware, Florida, Georgia, Maryland, North Carolina, South Carolina, Virginia, D.C., and West Virginia. Column data includes total revenue for the school district, the state revenue for the school district, federal revenues for the school district, expenses for instructional staff, expenses for non-instructional staff, and some more. Here is a snippet of the school district data with revenue amounts from the federal government, state government, and local government. As stated before, the data includes expenses towards instruction staff and towards non-instruction staff. It also has a column for other expenses. And ultimately, when this data is analyzed with the state of Maryland school data, I want to uncover if more revenue produces more proficient or math proficient students. I'll have to conduct research on student math outcomes of these other states to accompany the project. Doing some preliminary descriptive analysis in Tableau, it shows that Florida spends the most revenue in their state's public schools, while DC spends the least. I'll continue to use Tableau to reveal any more patterns in the data between state and other features. I plan on using some scatter plots and more line graphs and any other models that will describe the data more thoroughly. Additionally, there will be research conducted on school rankings of these other states, particularly which states amongst this South Atlantic region are ranked between best and worse. Education statistics is an important assessment of school progress when it comes to maintaining federal and state mandated standards for education. I anticipate producing a comprehensive report on the multiple features of schools that produce high percentages of math proficient students.